Hello, hello, hello. So far we have dealt with domain and range. We've dealt with interval notation. So now we're going to talk about key features of functions, of those functions that like you've seen before, things that you've done before. But we're going to focus on certain aspects of those functions, those key features, as we have up here, all these keys. All right. So the first thing is we're just going to talk about what the key features we're going to look at from this actual lesson or in this actual lesson. So here are the key features. So we have x and y intercepts. We have our intervals when it comes to increasing, decreasing, constant, positive, negative. We have our max and mins, and then we have our end behavior, like what's happening at the end of those functions or end of those graphs. What's going on there? That's we're going to take a look at those. So those pieces there. So to start off, we're going to talk about our x-intercepts, x and y-intercepts. So when finding our x-intercepts of functions, we're going to set the function which is y, so f of x is the same thing as saying y, equal to 0, and then we're going to solve for x. Then when it comes to our graphing portion of it, we're going to find the x-intercepts on the graph, and we're going to find them by looking at the points where they cross the x-axis, where they intercept the x-axis. When they cross or intersect the x-axis, that means that we're going to get an x value, and it's going to be 0 for your y. So it's going to be a number for x, and it's going to be 0 for y, because it's crossing the x-axis. At the x-axis, y is equal to 0. So with this, again, whenever we're dealing with our x-intercepts on graphs, or even when we're talking about x-intercepts for like the functions itself, just looking at functions, we're going to have an answer of x equals x and a 0 for the ordered pair. When it comes to x-intercepts, we'll just say also x equals and a number. So that's where we're going to be looking at. We're going to be focusing on. But then also, that's how we do with the x-intercepts. That's talking about the y-intercepts. And let me erase this part, so we don't need that. There we go. All right. Now for your y-intercepts, we're finding the y-intercepts of the function by setting x equal to 0. So every x that we have, we're going to put a 0 in that spot. Every single x. Put a 0 there. And then we just solve for the function, or solve for y. Remember f of x, if they give you f of x equals some actual function there, that means we just change f of x to y, because f of x and y mean the same thing. And then we just go ahead and change it over and put substitute 0 in there, and then solve for y. And then when it comes to your graphs, we're going to look at, since x-intercepts cross the x-axis, the y-intercepts are going to cross the y-axis. It's going to intercept it, just like you're doing a football and somebody jumps in front of you and you intercept that ball and from the other team and they run back and hopefully get a touchdown and everything. That's what we're talking about, intercepting, cutting across, stopping that person. So when we're crossing that x-axis, or crossing, in this case, crossing the y-axis, that's when we have our y-intercept. And when it comes to y-intercept on the graph, we can say y equals again, or we're going to have the ordered pair that is 0 for the x, because we just set up here that we're set x equal to 0. So x is 0, and then we have a number for y. There's going to be some number there for y. And we'll talk about that when we actually get to that part and actually get to examples. So again, for x-intercepts, we're going to set the function equal to 0 and solve for x. When it comes to the y-intercepts, we're actually set x equal to 0 and solve for y. And intercepts on the graphs is when it crosses those parts, crosses the x-axis or crosses the y-axis. All right, so now let's go to an example where we talk about x-intercepts and y-intercepts and finding those.